We're here with Dan, a plasma scientist on the Magnetospheric Multiscale Mission. And Dan, I understand that you came on board with MMS just before launch. What exactly are you doing with MMS? And tell us a little bit about your journey so far.
Yeah, so I came onto the mission maybe a year or so before launch. We were really trying to get sort of the data pipeline system going and trying to really take everything we learned from laboratory calibration of our instruments to be ready to correct the data to get sort of physical units out of the data once it came down.
So once the spacecraft launched and everything came on and was working, tell me a little bit about the process of how you calibrate these instruments that are now flying in space.
The really wonderful thing about MMS that's very different from a lot of previous missions is that we have very similar instrumentation. So fundamentally, we have particle instruments, we have electromagnetic field instruments, but the fact that we have 4 spacecraft so close together and sort of very fast measurements and really high quality measurements means that there's a lot of different ways to actually check your answer on orbit. Okay. And so every instrument sort of has its role to play in measuring a certain quantity, but what we can actually do is certain instruments in the configuration that we're flying can measure the same thing. And so a lot of the calibration process, it really involved comparing data from multiple instruments to try to converge to see what we got as the right answer.
And how long did this calibration process take in the mission before you could actually get out there and start to get real data?
So we commissioned effectively over the summer 2015. And so we had a few months, got our first data down. It started to trickle down as instruments started to turn on, and we got data from one spacecraft at a time. And so as soon as we started getting data from one of the spacecraft, we started trying to take everything we saw coming down from the spacecraft and make sure that it was consistent with things we learned in the laboratory and what was different, and tried to reconcile that. And as we got data from other instruments, tried to compare with those as well. And so commissioning lasts effectively over the summer. And once we got into regular orbit operations in the fall, in September, we were ready to go. And really the big data delivery came this past March, where we really delivered what we thought were almost publication-ready data to the public for the first 6 months of the mission. And so it was a really fast turnaround, but we're quite happy with the way it turned out.
Well, I mean, that's interesting to think of. I mean, I hear about all this data that you've sent down, but what does that actual data look like? I mean, you just get numbers and zeros, and if so, how do you turn that into information about magnetic reconnection?
So I work for the Fast Plasma Investigation, which is effectively 64 different sensors looking off in different directions spread across the 4 spacecraft. 32 of those measure ions, what direction particles are coming from and at what energies, and 32 of them measure electrons. And so the data we get down is effectively an angular map. It has look directions and energies, and we get the number of particles that hit our detector. And so it is our job to take those numbers and take everything we know about the sensitivity of the instruments and how they may change on orbit and convert that into physical units that then scientists, including myself, can actually analyze and convert into things like number density, temperature, and pressure.